Um, I am Zhe and this is my Lab 3 Black Hole Lab Report. Here's an introduction. In this lab, we need to find the mass of the black hole with coding. Also, we need to find out the initial velocity of the spaceship that can travel close to the black hole without being dragged into the black hole. Here's my model, and the main principle is still Newton's second law, but here we have a slight difference from the previous labs. Here we use F is equal to delta P over delta T. Well, in previous labs we used F is equal to ma. This is only a variation to that because we mainly talk about the motion of the objects in space. That's why we need to use the momentum more. And also we need to talk about angular momentum. Fnet is composed of the Fnet in parallel position and Fnet in perpendicular direction. So here's my experiment. So for part 1, we need to find out the mass of the black hole. So here's some data we need to clarify. For example, the mass of the star is 2 times 10 to the 30th, and the delta t is 800 and 6400, and the initial time is 0. And here is the part 2, and we used we find out the velocity using the f from the black hole on the planet, and then we find out the Fnet on the ship, and also then we found out that the mass of the black hole is 2.75886 times 10 to the 34, and then Fnet is 1.8 times 10 to the 29th, and that is composed of the Fnet parallel and the Fnet perpendicular. And for part 2, we found out that the initial velocity is negative 4.8 times 10 to the 7th and 2.5 times 10 to the 6th meters per second. And the shortest distance from the spaceship to the black hole is 2.4 times 10 to the 8th meters. So in conclusion, we found out that the mass is about 2.75 times 10 to the 34th, and the initial velocity is as shown, and the shortest distance is 2.4 times 10 to the 8th meters. Alright, that's all. Thanks for watching.